This is a quadratic inequality question. If you were to expand out the brackets, you get an x squared term. And the key to dealing with this is to draw a sketch of the graph. When I say the graph, I mean you have to set up the function y equals x minus 2, x plus 3, and then sketch it. So we'll get two roots here, 2 and minus 3, when y is equal to 0. And we can put these on the graph, minus 3 and 2. And then because it's a happy quadratic, we've got a leading x squared term. It will look a bit like this. Okay, it doesn't have to be super accurate. Actually, the turning point will be before the origin, before like the y-axis, because it's always halfway in between, but that's not essential. There we have our graph. Now we're interested in where it's greater than 0. So it's greater than 0 here. This is where y is greater than 0, and also here, whereas it's less than 0 below, and equal to 0 for minus 3 and 2. So you can also put some little arrows in, but we're going to get x is less than minus 3 or x is greater than 2. Now that would get me 1 mark, but it's asked me to write it in set notation, so you need to be aware of how to do this. And what you do is you open a set, you say the set of x such that x is less than minus 3. So it's very similar, but you need to define it as a set. And instead of or, we use set notation, which is the union. That essentially means or. You do the same again, the set of x such that x is greater than 2. And that is our final answer. Just one more thing to think about. You might also be asked, or instead, to write it in interval notation. And then it would be the following. It would be open bracket minus infinity, comma, minus 3. And then, because it's not including minus 3, it'd be a bracket like this again. If you're including minus 3, it'd be a square bracket. And then, again, it's union 2 to infinity. So just be aware of that notation as well. That's called interval notation, whereas my actual answer is set notation.